find the basis of
What are all the bases? So one basis that you know for say square integrable trajectories is your Fourier transforms. So you can try moving along all the Fourier transform directions and see whether it reduces or not. I can add delta into e raised to j omega t and see whether my trajectory increases or decreases. That is one set of bases. What is another basis that I can take?
So for functions like this, can you not take that differential form?
What differential form?
So like differential equation of that function that will give us a family of curves that we can shift and check.
What differential equation will give you the set of all square integrable trajectories?
No, for this particular bell curve.
Oh, no, I'm not looking at a bell curve. The vector space that I'm looking at is a set of all trajectories that have support between A and B. I'm not looking at a bell curve. I'm not even looking at continuity, I'm not looking at differentiability, nothing. I don't have any of these conditions. These need not even be functions, they can actually be distributions. Right? Direct delta, for example. Direct delta is not a function, it's a distribution. Why is direct delta not a function? What do you mean by a function, a map? So what are these things? What are these definitions? So what is the difference between a function and a map?
like it is one-to-one mapping, then it is a function. And if it is one-to-many, then it is not a function.
Right. So if it is so a function by nature, each point in the domain goes to a unique point in the codomain. So you cannot have one point in the domain going to multiple points in the codomain. If you look at direct delta, at 0 you are going to 2 points. You are going to 0 and infinity at 0. Right? It's a limit point of functions. But direct delta in itself is not a function. Step. So we've been, throughout our undergrad studies, we've been told step function and direct delta function. Both of these are not functions. Step is a distribution, direct delta is a distribution. So when I'm looking at finitely supported here, I also include distributions. I'm not just including functions. So I'm looking at a bigger space than even functions. So forget differentiability. There is no differentiability, there is no continuity, there is no differentiability, nothing. But I still want to do optimization here because my vector space does contain trajectories that are not differentiable or continuous. But I can still do optimization. How?
Can you take k minus a divided by p minus a?
A minus?
K minus a divided by p minus a.
What is k minus a divided? What is k?
Like,
What is?
the x-axis is defined by k.
Okay, so first thing,